Welcome to another tutorial from Math Zone African Motives. Today, we'll be tackling two key matrix concepts: solving systems of equations using Cramer's rule, and understanding minors and cofactors of a determinant. First, let's look at our objectives. By the end of this video, you will be able to solve a system of two linear equations using Cramer's rule, and you will be able to calculate the minor and cofactor of a specific element within a 3x3 determinant. Let's begin with our first problem, 2.2. The question asks us to solve for x and y using Cramer's rule, given the system of equations. 2x plus y equals 6, and x minus y equals 3. Cramer's rule provides a formulaic way to solve systems of linear equations using determinants. But before we can use it, we need to list the formulas for solving for x and y. The formula for x is the determinant of d subscript x divided by the determinant of d. The formula for y is the determinant of d subscript y divided by the determinant of d. Let's briefly explain what each part of the formula means. D is the determinant of the coefficient matrix, which we form from the coefficients of the x and y variables in our equations. For our system, the coefficient matrix contains the coefficients 2 and 1 from the first equation and 1 and -1 from the second equation. The determinant d is calculated from this matrix. dx is the determinant where we replace the x coefficient column in d with the constants from the right side of our equations. So the first column becomes 6 and 3. Similarly, di is the determinant where we replace the y coefficient column in d with the constants. The second column becomes 6 and 3. With this understanding, we can now proceed to solve the problem by calculating each of these three determinants. Our first step is to calculate the determinant d of the coefficient matrix. Remember, the coefficient matrix is formed by the numbers in front of x and y in our original equations. We need to find the determinant of the matrix containing 2, 1, 1, and -1. The formula for a 2x2 determinant is the product of the main diagonal elements minus the product of the anti-diagonal elements. That is, AD minus BC. Applying this to our matrix D, we have 2 times -1 minus 1 times y. This gives us -2 minus 1, which equals -3. So the determinant D is -3. Next, we will calculate the determinant d subscript x, which is used to solve for x. To get dx, we replace the x coefficients in d with the constants from our equations, which are 6 and 3. So we find the determinant of the matrix containing 6, 1, 3, and -1. Again, we use our determinant formula, a d minus bc. For dx, this is 6 times -1 minus 1 times 3. This simplifies to -6 minus 3, which is -9, so dx is -9. Now we will calculate the determinant d subscript y, which is used to solve for y. To get di, we replace the y coefficients in d with the constants 6 and 3. So we need the determinant of the matrix containing 2, 6, 1, and 3. We use the same determinant formula, a d minus bc. For di, this is 2 times 3 minus 6 times 1. This gives us 6 minus 6, which equals 0, so di is 0. With d, dx, and di calculated, we can now find our solutions for x and y using the Cramer's rule formulas. First, let's solve for x. The formula is det ddx divided by det d. We found det dx is 9 and dt d is 3. So x equals 9 divided by 3. The result is 3. So x equals 3. Next, let's solve for y. The formula is d divided by d. We found d is 0 and d is the 3. So y equals 0 divided by 3. The result is 0, so y equals 0. Therefore, the solution to the system of equations using Cramer's rule is x equals 3 and y equals 0. Let's quickly check this answer. Substituting x also 3 and y beta 0 into our first equation, 2, 3 plus 0 equals 6, which is true. Substituting into the second equation, 3 equals to 0 equals 3, which is also true. The solution is correct. We have successfully solved problem 2.2. Now let's move on to problem 2.3. The question gives us a 3 by 3 determinant D and asks us to determine the value of the minor of -1 and the value of the cofactor of 5. First, let's address question 2.3.1. Determine the value of the minor of -1. Let's start by defining what a minor is. The minor of an element in a determinant is the determinant of the smaller matrix that remains after deleting the row and column of that element. This definition means that to find the minor of -1, we first need to locate -1 in our determinant. -1 is in the second row and second column. Now we delete that entire row and column. The elements that remain form a 2 by 2 submatrix. The minor of -1, which we can denote as M sub 22, is the determinant of this remaining submatrix, 2, 1, 4, 5. To find the value of this minor, we simply calculate the determinant of this 2 by 2 matrix. Using our formula AD minus BC, we get 2 times 5 minus 1 times 4. This is 10 minus 4, which equals 6. Therefore, the value of the minor of -1 is 6. Now let's move on to the second part of the problem, 2.32. Determine the value of the cofactor of 5. A cofactor is closely related to a minor. The cofactor of an element, denoted by A sub ij, is calculated using this formula. The formula for the cofactor A sub ij is -1 to the power of I plus j, multiplied by the minor of that element, M sub ij. Here I is the row number and j is the column number. So to find the cofactor of 5, we need two things: the minor of 5 and the position of 5 to determine the sign. First, let's locate the element 5. It is in the third row and third column. This means our I is 3 and our j is 3. To find the minor of 5, M sub 33, we delete the third row and third column. The remaining submatrix is 2 por 2, 3 por 1. Calculating this minor, we get 2 times a 1 minus 2 times 3, which is 2 plus 6, giving us a minor of 4. Now we have the minor. Let's find the cofactor using our formula. A sub 33 is -1 to the power of 3 plus 3 times the minor we just found, 4. Since 3 plus 3 is 6, which is an even number, -1 to the power of 6 is +1. So we have +1 times 4. This gives us a final answer of 4. The value of the cofactor of 5 is 4. Let's quickly recap what we've accomplished in this tutorial. First, we successfully solved a system of linear equations using Cramer's rule, which involved calculating the determinants d, dx, and die. Second, we determined the minor of an element by finding the determinant of the submatrix that remains after deleting the element's row and column. And third, we calculated the cofactor of an element by combining its minor with a sign that is determined by its position in the determinant. These are fundamental skills in matrix algebra that build the foundation for more advanced topics. Great job working through these problems with us. Subscribe for more tutorials from Math Zone African Motives to continue your learning journey. Thank you for watching.